Hi, we're going to take a look at using function notation. I'm using this note sheet that you should have in your possession, but if you don't, there's a link to it on the lesson plans. And this is a pretty blank one, but at times I might be referring to one that I've already filled out behind it. The first two examples at the top are absolutely nothing new. It's just plugging in an x value and getting out a y value. So if I were you, maybe as a warmer-upper, complete these two, but I've got those written out for you right here if you need to pause the video to check your work, which would be a good idea. Well, that's just the normal plug in x, get out y. Hopefully you've done that. Let's now take a closer look at what's going to change with this lesson. And I'm going to zoom in here, hold on. With these two problems that were already typed out, I've just taken the exact same problems that were above, and it used to say y equals 6x minus 4, and that's replaced with f of x equals 6x minus 4. Up above we had a y equals blah 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 blah. We just changed it with g of x. So the only difference right now is we are getting a new symbol in place of y, and that's the function symbol. This says function f, and it's using variable x. You see that? Function g, and it's using variable x. It's like giving a function a name, but the plug-in process is still the same. In this problem up above, we plugged in a 3. So now where you see f of x, you write f of 3 because you're plugging in x equals 3. Where you see an x, you see a 3. We plugged in a 6 up above, so this is g of 6. And where you see an x, you see a 6. Nothing else has changed. We're just changing what the symbolism looks like. And you can think of it as giving your function a name. So now every function out there in the world is not named y. Some might be named f, some might be named g, a. You can just give whatever name you need. So that might seem a little weird. Why are we naming functions? But I'm going to give you an example where naming a function helps give a little context to the situation. So I made up a very, very easy scenario. A store earns a profit of $2.50 per t-shirt. And if you were to write an equation to represent that, you would say y equals 2.50x. And in this case, x equals the number of t-shirts. That's very true. There's nothing wrong with that. But we can make it a little bit better using function notation. So we could say, I need a p here. P equals 250t. Now we're personalizing a little bit. Profit equals $2.50 per t-shirt sold. Same thing as that, but now it's a little bit more personalized. And I can go one step further and call this function notation. P of t equals 250t. Of course, we use the p because it can represent profit. We use the t because it's representing the number of t-shirts. And P of t is just a way to write what we used to use in place. Well, P of t is a way to replace y. So the function notation can help give you a little bit of idea of what's going on in the scenario because it's a little bit more specific than y's and x's. So I'm back on the note sheet, and we go down to this next section. And what you should notice about this next section is we have a function a function v, and a function t. Or function p, and they all have different equations. So now when you're asked to plug into a function, you'll need to take a look, and I'm going to zoom in here a little bit. You need to take a look and make sure you're using the correct one. A of 12 means you better find function a and plug in a 12. So that means I'm going to head up there and use that one. V of 30 means, hey, better use that one. P of negative 4 says, hey, you better use that one. They don't have to be all lined up like this. A of negative 7 means I'm going to go back here and use this one. So I'm going to show you my completed versions of these. So I have the completed version of all these. You see my answers. You should be working these out on your own, pausing the video to get some good practice. And then after you do that, you can compare to my work, which is a little bit of chicken scratch. Plugged in a 12 there. So you should be able to see, for example, when I did P of negative 4, p of negative 4 means I go up to function p, and wherever I see a t, I plug in a negative 4. And that's what this is telling me. A negative 4 goes in for t, so where I see a t, I plug in a negative 4. After that, it's the same as it used to be. Just do the arithmetic. Then this last problem down here below gives you a function m of x. The name of the function is function m. It's using variable x. And go ahead and read what this is asking you to do. And you should pause the video and complete that, and then compare it to the work that I'm going to show you here in a few seconds. So there's my completed work on function m of x. Notice I use domain and range. We're used to saying x and y. We could also say, in this case, x and m of x, because m of x is taking over for the y. But nothing has changed but the symbolism. So when you're doing this function notation, just know that it's the same old plug in an x, get out a y, just with fancier writing. See you later.